In this video, let's calculate the utilities of the workers when they work in this fashion, and also let's see under what condition they choose to work as a team where they share the output only. So first things first, let's just zoom out to get more space because we need to work with the math here, and we need to have all the data in front of us. We need the wage, we need the effort levels, because that's how we find the utilities of the guys, right? Is the difference between the income and the cost of effort. So the utility of the first guy, which is going to be the same as the utility of the second guy, is the difference between his wage, so wage minus the cost of effort, and the cost of effort is 1/2 theta times the effort of this guy to the power of 2. Now it's a matter of substitution because we found everything. This is the wage, right? 1/2 times all of that, so we write it 1/2 times p square beta square divided by theta minus the cost of effort, and the cost of effort is going to be 1/2 multiplied with theta times the effort level to the power of 2. This is the effort level, so we raise all of it to the power of 2. What is 1/2 to the power of 2? That's just 1/4 multiplied with p square beta square over theta square. P square beta square over theta square. Okay, let's keep solving. We have to cancel out some stuff over here. Theta with theta. Theta and theta will go away. 1/2 times 1/4 is 1/8 times p square beta square divided by theta. And we also have the other term. Let's write it as well. We have 1/2 p square beta square divided by theta. We subtract them. What can we see here? We have a subtraction of the same term, basically, p square beta square over theta, but with different coefficients. We subtract 1/2 and 1/8, meaning we can subtract the coefficients. 1/2 minus 1/8. Let's do it over here real fast. 1/2 minus 1/8. We have different denominators, so let's make it in a common denominator. We multiply the first fraction by 4, and we would get 4 minus 1 divided by 8, which is equal to 3/8. So the result over here is going to be that the utility of either of the guys, because it's the same, is 3/8. 3/8 multiplied with, what was it? This term, p square beta square divided by theta. Let's compare this utility with what happened in part B when they were agreeing on the effort level to notice the difference. So this is the utility here. The other one was somewhere to the left. Let's have a look. Yes. So this is the wage, and the utility was this one, 1/2 p square beta square and theta. Let me just crop it to compare it. This was the utility before. So this was the utility before. Okay. Yes. What can we notice? The utility right now is smaller because 3/8 is smaller than 1/2, right? 3/8 is lower than 1/2, meaning that the utility decreased. The utility decreased because they did not agree on the effort levels. And one last thing is to compare this utility of working as a team in this fashion where they share the output only relative to the utility of working individually, to see what team effect they need to accept to work as a team. So we're going to compare this utility level, which is 3/8 times all that. The utility of a team now must be greater than the utility of working individually. So the utility of working as a team is at this moment 3/8 times p square beta square divided by theta, and the utility individually is what we found in the beginning of the question, somewhere over here. Just a second. What was it? Yeah, no, this is C, part A. Yeah, here. So that utility was equal to, where was it? Here. 1/2 p square over theta. Let's compare it. 1/2 p square over theta. So we go here. We just said 1/2 p square over theta. 1/2, like that. Now, cancel out whatever we can. What can we cancel? P square, theta, theta. 3/8 and 1/2. Okay. Basically, we have to divide 3/8 by 1/2. So if we get rid of 3/8 over here, let's divide 1/2 by 3/8. 1/2 divided by 3/8 means multiplying with the, how do you call that? Opposite, I think. 8/3. 8 and 2 cancel out, so 8 divided by 2 is 4. 8 divided by 2 is 4, so that's going to be 4/3. Meaning that 4/3 times, hold on, 4/3 times 1/2. Okay, so I just figured the faster and simpler way to do it. Let me just do it real fast right now. What's 3/8? That's 1/2 multiplied with 3 divided by 4, right? 3/4 times 1/2, we get to the same answer. So If that is the case, what are we left with? We're left with this thing multiplied with beta square is greater than 1 over 2. So that's going to be greater than 1 over 2 times 1, right? After we cancel out everything, we can write as 1 because it's not changing the result. It's just for the sake of the math to see what this inequality will look like. 1 over 2 with 1 over 2 cancel out. So what we have now is 3 over 4. What we have now is 3 over 4 times beta square is greater than 1. Meaning that beta square is greater than 1 divided by 3 over 4, and that's where we get to what I was trying to do over here, but I thought it's going to be too complicated to explain it like that. So 1 divided by 3 over 4 is just 4 over 3. We basically take this one to the other side. Beta square is greater than 4 over 3. What is 4 over 3? That's what's 4 over 3? Actually, you know what? Let me just write like that. Beta is greater than square root of 4 over 3. Right? Square root of 4 divided by 3. So beta is greater than square root of 4, that's 2 divided by square root of 3. 2 divided by square root of 3 is equal to 1.15. So beta must be greater than 1.15. Now notice, before, if beta was greater than 1, the worker was willing to accept to work as a team. Now that team effect must be greater than 1. It has to be but greater than 1.15. Why do we need a bigger team effect to induce the worker to work as a team? Because of this free riding thing. They know that if they work as a team now, but without agreeing on the effort, the synergy is going to be lower. So because the synergy effect is going to be lower, there is less benefit of working as a team. They will produce less, they'll make less money, and so on. So the benefit of working as a team is going down, meaning that in order to accept that, they must have a higher benefit to motivate them to accept working as a team versus working alone. So this was all the highlight of the question. We just had to compare the results in part B with the results in part C to notice the difference, what it means to agree beforehand on something, like putting in enough effort, versus just, shooting in the dark. Basically, yeah, let's share the output, but everyone is going to work as much as he likes. And, that's where there is an incentive for free riding. Anyway, hope this all makes somewhat sense. In the next video, we go to part D.